All right, welcome back to trigonometry. Today, we're going to talk about even and odd functions. Okay, you may have learned this in algebra 2 or college algebra a little bit. We're just going to take a real quick review of it so we can talk about even and odd functions. So I've got a function that we're going to work with, which is going to be f of x equals x over x squared plus 1. And I'm just going to go ahead and plot a couple of points through here. We're just going to see what happens with this thing. Right? So we have our x, we have our y value, which is f of x, and I'm just going to plug in some points and just see what happens. So if I plug in 0, right, we have 0 over 0 squared plus 1. This will be 0 over 1, which is, of course, 0. So I put in x equals 0. The answer is 0. Let me plug in 1. So we're going to say x is 1. So we're going to have 1 over 1 squared plus 1, which is going to be 1 over 1 plus 1, which is 1 over 2. So we're going to say 1, that's 1 half. Remember, that's about 0.5. So 0.5. Okay. I plug in 2. We're going to say this is 2 squared plus 1. So that's going to be 2 over 4 plus 1. So we end up with 2/5. That's going to be 2. And we end up with 2/5. That's about 0.4. Actually, that is 0.4 exactly. Okay, let's go ahead and plug in 3. So we're going to plug in 3. So we're going to have 3 over 3 squared plus 1. So we have 3 over 9 plus 1, which is going to be 3 over 10. So we have 3/3 or zero point 0.3. Okay, I put the decimals in here just so I give a better chance of graphing them. And we can see it's 0.5, 0.4, zero point 0.3, etc. Okay, now I'm going to go ahead and we're going to plug in negative numbers. So we have -1. So x equals -1. We'll plug that in. So we have -1 over -1 squared plus 1. That'll be -1 over 1. -1 squared is 1 plus 1. -1 over 2. So we have -1 half. Okay. Plug in -2. So we go ahead and plug in -2. So we have -2 over -2 squared plus 1. It's going to be -2 over -2 squared is going to be 4. 4 plus 1. We have -2/5. -2/5. So what I'm trying to get us to start thinking about here is I plug in, I said f of 1 and f of -1. F of 1 was equal to half. F of -1 was equal to -half. F of 2 is equal to 2/5. F of -2 is equal to -2/5. If I plug in 3, am I going to get -3/10? Okay, so let's plug in 3 and see what happens. We have -3 over -3 squared plus 1. That's going to be -3 over. -3 squared is going to be 9 plus 1. We have -3/10. -3/10. So what I try to demonstrate here is it looks like if I put the negative in, I kind of get the negative y value. So I put a negative x, I get a negative y out. So what I'm going to say is that if we have f of x equals f of x, okay, f of negative x is equal to negative f of x. It's almost as if the negative sign floats through the function. That doesn't actually happen, but it looks like it does, okay? This is known as odd. This is known as an odd function. Okay, not odd as in it's misunderstood. It's odd like 1, 3, 5, 7 are odd. Okay, so it's an odd function. It's got a specific kind of symmetry. If we graph this thing, okay, this is why I went ahead and said we have a 0.5, 0.4, 0.3. So we can go up here and we can say, okay, here's 0.5, here's 0.4, here's 0.3. So at 0, we were at here at 0. At 1, we were up here at 0.5. At 2, we were up here at 0.4. At 3, we were down here at 0.3. And it's going to keep getting smaller and smaller and smaller. At -1, we were at -half. Okay, so let's go ahead and take a look at this. This is -half down here. At -2, we were at negative 0.4. And at -3, we're at negative 0.3. So this graph looks like, okay, so it comes up like this, comes down, and does this kind of a piece here. Okay, and that's what this graph looks like. The idea of odd symmetry is that if I take this piece up here, okay, when I say up here, I mean, let's go, I want there. When I take this piece up here and I flip it, it's almost as if I could flip it through the origin and have a mirror effect going on in quadrant number three. So I could take quadrant number one, kind of fold it over and get to quadrant number three, and they are exactly the same. That's odd symmetry. Okay, it's symmetric about the origin. Okay, that's what odd functions mean. Okay, pick another function. Let me go ahead and pick f of x equals 1 over x squared plus 1. And I'm going to do the same thing. I'm just going to pick some points, plot them, and then see what happens here. So we have the x, we have a y value. It's 1 over x squared plus 1. I plug in 0. We have 1 over 0 squared plus 1. That's 1 over 0 plus 1 is 1. And we end up with a 1. Okay, I plug in -1 here. No, let's plug in positives. Okay, so we have 1 over 1 squared plus 1. That's going to be 1 over 1 plus 1 is equal to 2. So we have 1 over 2, 0.5. Okay, I plug in 2. We're going to say this is 1 over 2 squared plus 1. That's going to be 1 over 2 squared is 4. 4 plus 1 is equal to 5. So it's going to be 0.2. So we have 1/5 here, 0.2. So this was 1/5 equals 0.2. If I plug in 3, okay, so let's see here. We're going to go ahead and say this. So if I plug in 3, right, we have 1 rather, over 3 squared plus 1. And that's going to be 1 over 3 squared is 9 plus 1. We have 1 over 10, which is 0.1. So we are 1 over 10, 0.1. Okay, let's try the negatives. Okay, just for the sake of doing this, bear with me. I plug in a -1, we're going to have 1 over -1 squared plus 1. That's 1 over -1 squared is 1 plus 1. We have 1 over 2. So we have 1 over 2 of 0.5 here. Right? -2. Right? We're going to say this is 1 over -2 squared plus 1. This is still 1 over 4 plus 1, which is 1 over 5. So we have 1 over 5 or 0.2. Right? And then -3, we plug in this and we end up with 1 over -3 squared plus 1, and that's equal to 1 over 9 plus 1, which is 1 over 10. So in this case, it looks like we have f of -x is equal to f of x. It's like the f ate the negative sign. Again, that's not what really happens, but that's kind of how to think about it. Okay, if I went to graph this piece, right, at 0, we're all the way up here at 1, and then we can go ahead and say, okay, well, we're at 0.5, 0.2, and 0.1. So here we're going to have 0.5, 0.2, and 0.1. So we're here and then here. So this function looks something like this. Okay, so here, here, and here. So we're going to come down, and it kind of looks something like this. Okay, so with this function, graphically, it almost looks like if I took my left-hand side, my right-hand side here, and folded it over, it would be the same as my left-hand side. That's what even functions tend to do. So this is even symmetry. So the idea is f of -x is equal to f of x. That's even. Okay? One of the reasons we call them even and odd is that x squared, x to the fourth, x to the sixth, x to the eighth, dot, 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 all have the same kind of a shape, okay? Going back to odds, we have x, x cubed, x to the fifth, x to the seventh, dot, dot, dot. They all tend to have this kind of symmetry attached to them, so we can go ahead and do that. Now, it's possible, it's actually quite frequent, that a function doesn't have even or odd symmetry. So functions can be neither even nor odd. So functions can be neither even nor odd. Okay, so they could be nothing. And what's that going to look like? Well, let's pick one. We have y is equal to x minus 3 squared. Okay, which is like, oh, that might be an even function. Like, but it isn't, because you can go back to your algebra classes and say, okay, this is a horizontal shift of 1, 2, 3, and then we're going to have a parabola with a shift of 3 to it. And you can say, well, this does have symmetry. Like, yes, it does, but it doesn't have symmetry about the y-axis. So it's not an even function. It's neither even or odd. Okay, it does have a symmetry. That's okay, but it doesn't have this special symmetry about the y-axis. So in order to have the symmetry, it has to be about the origin, it has to be about the y-axis. So for odd functions, f of negative x is equal to negative f of x. For even, f of negative x just eats the regular one. Okay, now, why do I care about this for trigonometry? Like, aha. So sine is an odd function. Okay, tangent is an odd function. Okay, and then cosine is an even function. Okay, so you're going to use different pieces of this. You're going to say, oh, well, sine of negative x is equal to negative sine of x. We'll get to the graphing in a little bit. Cosine of negative x is equal to cosine of x. Okay, it just eats the negative sign. If I went ahead and showed you something like this, let me see if I can't set this up and show it to you. We have Desmos here. I'm just going to go ahead and type this in. We're not quite ready for this, but we're going to show it to you anyway. I'm going to say, okay, here's y is equal to sine, just sine of x. Desmos is fantastic. It graphs a lot of stuff for us. And as we get into the graphing, we'll use some of this in order to help us. But we'll go ahead and we'll say this. How about y is equal to x minus x cubed over 3, and I'm going to say factorial. Factorial, it's not a really excited 3. Okay, that's not what it's doing. It's 3 times 2 times 1. Okay, and then we're going to, so you see how well this polynomial like tracks what the sine function is. If I start adding extra terms, so if I add an x to the fifth over 5 factorial, okay, notice it hugs it a little bit closer here. It's a little bit more approximating on it. Okay, we can keep going. We can say minus x to the 7th over 7 factorial. So divided by 7. And I don't want to write out 7 times 6 times 5 times 4 times 3 times 2 times 1. But you see that it got a little bit closer and it approximates it just a little bit more. If we take this and go out until infinity, then we'll have this, the curves will be exactly the same. Okay. This is a thing you're going to learn in calculus too. So we don't have to worry about that right now, but it's a way of like, well, can we approximate a sine function with a polynomial? Like, well, kind of. And, we're going to have little bounds for like, it depends on how far away. So it got it really good between, it looks like pi over 2 and maybe negative pi kind of a thing. So it got it pretty far away. Maybe negative pi to pi. It was actually pretty good to figure that out. Let's look at cosine, and I'll go ahead and exit these guys out. So I'll say y is equal to cosine x, c, cosine. Okay, and you see what cosine looks like. And again, we will get into the graphing as we go forward. Okay, but I could also say that cosine is equal, so I could say y equals 1 minus x squared over 2, right? 2 factorial will be 2 times 1 or 2. And you see how close the blue line matches with the red line. I'm like, well, that's not that good. Like, no, not yet. But as I start adding terms, so if I say, what about x to the 4th over 4 factorial? Okay, technically this would be 2 factorial, but 2 times 1 is the same as 2. So it hugs it a little bit closer. And then we could just start adding more terms in here. So we can say minus x to the 6th power divided by 6 factorial, right? And you can see it gets, again, it gets closer and closer. The blue line and the red line get closer and closer and closer together, all right? Until it gets to a certain point. It doesn't stay good forever, but it stays good until you have so many terms. Again, if we go out for infinity, if we go out and like expand this thing out to way more terms than I would ever want to write, then the blue line and the red line will be the same. Notice what the shape of the cosine is it can be approximated by all even polynomials. Cosine is an even function. I go back to sine. We're going to have x cubed, x to the 5th, x to the 7th, to the 9th, to the 11th, to the 13th. dot, dot, dot. These are all approximated by odd polynomials. Sine is an odd function. So we're going to need that a little bit later as we go through different identities and different ways of calculating things. But the idea of you can calculate, say, go back to something up here. I'm sorry about this. Let's get rid of me, and then we'll go back up here. Okay, so just real quick, there's more angles that you know without having to know them. So if I want the cosine of, say, negative pi over 4, negative pi over 4 is down here somewhere. It's in the quadrant 4. Well, I know that cosine, so I know that because it's an even function, I can say this is cosine of pi over 4, and that's going to be the square root of 2 over 2. So I've just doubled the number of angles that I can just deal with this without a calculator, and then voila, here we go. I have exact values for all of these things. It's kind of neat when when your questions are being asked, we're asking you for exact values. But that's how and why we use even and odd in manipulating evaluations for trigonometric ratios. Okay, so I hope you found that somewhat useful, and I hope you enjoyed the approximation, the polynomial approximation of sine and cosine. We'll get to the graphs a bit later. But I'm going to say thank you very much for watching, and I will see you next time. Good job.